Okay. So lecture 4, polynomials. First of all, let's define the word. Those of you from art class, what does poly mean? Like a polychromatic drawing in art class. What do you say? 3? Okay.
I know like 3 or more.
It just means multiple.
That's what I thought it meant many.
Yeah.
So 3 or more, or 3 more than 1. So poly is just many. Okay. I'm sorry, I'm going to kick that.
No, it's my fault.
I'm done walking there unless someone has a question. So and then nomial is just a fancy word. Nomial. It's just a fancy word for term. So polynomial is just many terms. And from our definition today, what separates terms? Addition, subtraction. So it's just multiple, could be lots of them. Now we do have some specific names, right? So like if I just give you, here's some examples. If I just give you 4x, that's one term, right? What's our special name for that? What'd you say? Nice and loud.
Binomial.
That's 2.
Whoops.
So if I have like
That makes sense.
4x squared plus 2, that would be a binomial.
Would it be a monomial?
It would be a monomial. Kind of like, let's go back to art class, kind of like a monochromatic drawing. It's generally just one color, right? It's on white and you do it in pencil or something. Monochromatic, one color. So binomial is 2, and then of course we have, if I have 4x squared plus 2x plus 1, that's going to be a trinomial. Like the bicycle and the tricycle and the monocycle. Actually, unicycle. That ruined my word. Everything else is just a polynomial. There's no other special name past that. Okay. All right. Now, a little note. What is not polynomials? How do we identify things that are not polynomial? Well, there's 3, which is actually just going to be 2, because 2 of them are connected. So let's go with A. Okay. We learned these the other day, or reviewed these the other day. Like if I have x to the negative second, negative integers, negative integers in the exponent are not polynomials. Okay. In fact, we learned the other day, or reviewed, that how do I get rid of that negative exponent? Put a 1 over it, right? So 1 over x squared. So if I have a variable with an exponent in the denominator, that's also not a polynomial. In fact, we have a name for these. And what type of function are those? Math students.
Fractions.
Okay, so fractions is a correct term, but it's not the correct function term. So in 5th grade, when you learn fractions, I really think 5th grade teachers need to switch their language. And rather than calling them fractions, they should call them, what did you say? Not improper, because that's a specific type of fraction.
I mean, we have them under
What'd you say? Rational. These are actually rational, and that's going to be actually our lecture 5. We're going to talk about rational functions. Those are rational, those are not polynomials. Okay? Those are rationals, not polynomials. Now I told you there were 3, actually 2, because 2 or 1. These are 2 are the same. Whether it be a negative exponent or move to the denominator, however it's written, those are rational functions. There's one other thing that's not the polynomial, and that's going to be like x to the 1/2. If I have a fractional exponent. Okay? Now what type of function is that? What'd you say?
A radical, like a root.
Radical. This is the same thing as the square root of 2. So these are actually called radical functions. And they could be a cubed root or a 4th root or a 5th root. But if I have fractional exponents, that's not a polynomial, that's a radical. So fractional exponents are radicals. These two, however it's written, are rational. Polynomials don't have those type of exponents. Yes?
Would it
square root of 2, didn't it?
Yeah.
Okay.
Okay, sorry, I thought I was going crazy.
Okay, well, that being aside, you might be going crazy, but I should have written X right there. Yeah, thank you. Okay, we caught my one mistake for the year, so we're good the rest of the year. We'll be perfect. I just got to make that one error right away, and then you're good for the year. All right, so these are not polynomials, these are rationals or radicals. How about this one? Just on a little side note, what about this one, 2 to the x, where the exponent is actually a variable? Is that a polynomial?
Yes? Well, no, because there's not multiple times.
What type of function is that called? Should have said it in algebra 2. If I were to graph it, it looks something like that.
Exponential.
Exponential. This is an exponential function. So your exponent has to be a positive integer, or I should say a non-negative integer. So it could be 0. Any non-negative integer. All right. So we got polynomials figured out. We know what they are. We good with that? All right. So Roman number 1, if you will. Those of you who like formal notes. When it comes to polynomials, the topic is always, I'm not going to talk too much about this, but someone in layman's terms, in non-math terms, non-math language, what are like terms? Yes?
Terms that are alike, like similar.
Got to define like. You can't use the word like in
Similar.
definition. What'd you say?
Similar.
In what way?
Terms that like have the same like you know
I do know actually.
yeah.
I just need you to tell me.
Okay, like terms that have the same what's that word? Like
Hypertension.
What?
That's a word.
oh
She said what's that word?
like they have the same like structure almost, but they have like if you had like 2 and 17, they're both like just like whole, just like regular
Well,
numbers.
they're just whole numbers, right?
Yeah.
So they're like.
Yeah.
Yeah.
You could say that they're alike.
I don't know the word. I didn't.
It's coming out. It's coming out. As soon as we say it, you're gonna say, "That's what I meant to say." Yes.
Like X and like 2 are like has to be like
Because they have to be the same. What?
same
They have to be.
like integer or
Do you want to phone a friend? What'd you say?
how many are you?
Well, I'm looking for non-math terms. So just.
Are they like?
Do you know what she's looking for? She's phoning a friend. What'd you say? Well, they're similar, but in what way?
They have the same.
Mom and dad.
Like they
The same mom and dad.
have like
No, if I have the same
Same
mom, they have different dads.
No, not that either.
they have the same.
This is almost humorous. I want to keep this going. What?
Value?
Not the same value. No.
No, you're right. That's not it. They have like
Prime. No.
Let me give you. This is going to be kind of fun. Let me give you a couple examples, and maybe that'll tell you what word you're looking for. So, is x? Let's go 3x and 3x squared. Are those like terms?
No.
They're similar. They both have a 3 and an x.
But they're not like terms
Why are they not like terms?
because the 3x it just has
It's not squared.
what do you say?
What he said, yeah.
Why did you already say it?
What would
I
you
said it's
say?
not squared.
Yeah.
Okay, so like terms then have to have not only the same letter. Now in mathematics we would say not letter, but we would say variable. So they have the same variable, have the same letter, with the same
But they have to have the same
I heard someone say exponent.
exponents.
If I didn't hear that, I just made it up. So they have to have the same letter, the same
I
exponent.
said.
You said exponent? Okay. So like terms have to have the same letter and the same exponent. That's all there is to it. Okay.
I I heard someone.
That was kind of fun, actually. Wasted a little bit of time, but that's okay. We're good. Okay, so next time, Ava, you got it?
Mhm.
Okay, beautiful. So same letter with the same exponent. Now, what can I do with like terms? Combine, add, subtract, whatever. I'm not going to show this once, get you the idea. But if I had something like 4x plus 7x, what's my answer and why?
11x.
Why is it 11? It's not squared.
Yes,
It's just 11x. Why is it 11x? How did you get that?
They're like terms.
Okay, so what they're like terms. They both have the same letter, same power. So mathematically, algebraically, what we did was we took out what they have in common. What do they have in common? They have an x in common, so we took out the x and have 4 plus 7, and now we follow the order of operations. 4 plus 7 is 11x. That's why it's not 11x squared. Okay, you simply just combine the like terms by adding the coefficients. Okay? All right, like terms. Now, are we good with that?
Yeah.
Okay, we can add or subtract like terms. What if we had a subtraction sign here? Could I combine those?
No.
No, that would be my answer unless we're going to factor it out. But there's really, you can't combine those at all. Okay. All right, very good. Number 2. Do you have to have like terms in order to multiply?
No.
No, you can multiply any terms together, that doesn't matter. So absolutely, you can multiply any terms together. So if I had something like 3x times 4x squared, I think we did this the other day with our rules of exponents, right? Since it's all being multiplied, oh, here's going to go way back to like 6th grade, okay? Since it's all being multiplied, 3 times x times 4 times x squared, what property allows me to just multiply this? Because what's the answer?
12x cubed.
12x cubed. 3 times 4 is 12. And x times x squared is x cubed. What property from like 5th or 6th grade allows me to do that? What'd you say?
Well, the like order of operation.
Not order of operations, because we're all multiplying.
Okay.
So in PEMDAS, it's just the n.
Okay.
What property is it?
Oh.
Does it start with a what? Does not start with the D. I think you're thinking distributive. It's not distributive. Yes. Commutative.
Yes.
Allows me to move things around, right? Or we can actually apply what's called the associative property. So I can associate the 3 times the 4 and the x times the x squared, and that would give me 12x cubed. So I can associate, or I can move things around. I can commute. Like commutative, what's a commute? When I travel from my home to school in the morning, that's my commute. And my commute going home from work to home is exactly the same, right?
So we're just working on like the fact that 3 times 4 is the same as 4 times 3. Right?
That's commute.
Okay.
You switch things around with multiplication. Okay? Very good. So multiplying monomials are fairly easy. Now the famous, this is the one that is a pain in my existence. Okay, so what if I multiply, if we're doing this one, if we're multiplying binomials, like 2x minus 5 times x plus 1. All right, back when you were in elementary, what was the process you learned to multiply these two together?
Foil.
Foil? Anyone learn foil?
Yeah.
First outside, inside, last?
Like rainbow.
The rainbow, I always did the rainbow.
Or the box.
No, did anyone learn the box method?
Oh yeah.
Okay, I don't care which one you do, they're all legitimate. Just don't screw it up, okay? So I'm gonna use the rainbow, so just 2x times x gives me 2x squared. 2x times 1 gives me plus 2x. I'm gonna go ahead and stack them because I know that the outside and the inside are gonna be like terms. So negative 5 times x is negative 5x. Negative 5 times 1 is negative 5. And then you just combine your like terms. That should be something we've done many times. Now 4b, factoring, is going to be when I start here and I go backwards. It's the same thing, it's just going backwards. We're going to do that next week. Okay? Okay, let me show you one that a lot of people screw up, whether it be college algebra, pre-cal, calculus, whatever it is, they screw this one up. If I have something like 2x plus 3 squared. how do I do 2x plus 3 squared? Well, what does it mean? I have two of these binomials, right? I have 2x plus 3 times 2x plus 3, and then I have to use there is a shortcut, but I have to use the FOIL method. Okay? I can show you a shortcut to it if you want it, but you want to see the shortcut? You want to see the shortcut? I gotta have a majority of people want to see the shortcut.
Yeah.
Is there who wants to see the shortcut? It only works for squaring. It only works for squaring. Okay. So to square it, you simply take, what is 2x squared? 4x squared, right? What is 3 squared?
9.
That's 9. Multiply these together. What do you get? 2x times 3 is what?
6.
Double it. And there's your shortcut. It's the same thing as if you just FOIL it. So square, square, multiply, double. Just be careful. Don't do 2x plus 3 squared and give me 4x squared plus 9. That I struggle with every single time. I get mad, I get angry, start throwing things. Sometimes I cuss. I say things like, oh darn. So you don't want me to go there.
Oh my God.
Don't.
I can't believe you said that.
I even said on recording, I don't want to go there and use that type of language. So. Don't do that. Don't make me say that. All right. All right. So multiplying. Do we need to move on with multiplying? Are we good when we do like a trinomial times a trinomial? Are we good with that? Probably. All right. So should we try one?
Sure.
Yeah.
I'm going to put on the board, give you a couple minutes, and you try this one. Okay? All right. You try. Let's go with 2x minus 5 times x squared minus 3x plus 2. Binomial times a trinomial. Give that one a try. See what I did there? Give this one a try. Trinomial.
I said that earlier and nobody responded to me.
Thank you for courtesy laugh. I appreciate that.